So if we look at a quick overview of the reactions of aldehydes and ketones, we have an aldehyde, the two reactions that we can undergo with an aldehyde are we can further oxidize it onto a carboxylic acid, or we can reduce it back to the primary alcohol it had originally been oxidized from. Ketone, we can't further oxidize a ketone, but we can reduce it back to the secondary alcohol that it was produced from. Let's look at these reactions in more detail. Okay, so the first type of reaction we're going to look at is an oxidation of an aldehyde. So remember, we can oxidize molecules by adding acidified permanganate or acidified dichromate. In this case, the aldehyde functional group, the carbon that's attached to the double bond oxygen has the ability to have another bond to another oxygen. We can oxidize it further. So what we do is we add the permanganate or MnO4- /H+ reagent, and we turn it into a carboxylic acid. So remember, this is part of a longer process where an alcohol is oxidized to an aldehyde, or primary alcohol to an aldehyde and onto a carboxylic acid. Most of the time the aldehyde is just an intermediate product. Okay, so it happens in the middle of the reaction but not as the final product. So what if I wanted to produce some aldehyde? Well, this is a kind of a thought experiment that's quite important to go over. So if I wanted to produce an aldehyde, I would set up this type of equipment here, a round bottom flask attached to a Liebig condenser, and here I've got a thermometer to measure the temperature. Now you have to remember what I'm going to put in the bottom here is some ethanol, because remember we said an ethanol can be oxidized to an aldehyde and then it will be oxidized further onto a carboxylic acid. What we want to do is stop the reaction before it reacts into a carboxylic acid. So if we put the ethanol in here and we add to the ethanol some acidified dichromate, we can heat this reaction. Okay, so we're going to heat this reaction. Now I'm only going to heat it to 50 degrees Celsius. Now a way to do that would be to maybe place this in a water bath. That is and I measure the temperature of the bath of water it's in to about 50 degrees. So I heat this reaction. Now what that means is, as soon as, if this reaction is happening at 50 degrees, as soon as some ethanol is produced, ethanol has a boiling point. Ethanol is the aldehyde that's produced from ethanol, has a boiling point of 21 degrees. The ethanol will evaporate because it's hotter than 21 degrees, it's at 50 degrees, and it will go back in here and down this Liebig condenser, and it will convert back to, it will condense back to a liquid, and we will collect it here. Now the original reactant I had in here, the ethanol's boiling point is 78, so it will not boil and come off here. Okay, so what's going to happen is, as soon as the ethanol has been oxidized to produce ethanol, the ethanol will boil off and then be collected, so it won't have the opportunity to continue to react with the dichromate and produce a carboxylic acid. So this is a specific technique we use to stop the reaction halfway through. And remember, the reaction we're talking about is ethanol going to ethanal going to ethanoic acid, but we want to stop before it does the last reaction. So I set up the equipment like this. If I want to produce ketones, it's an entirely different matter. Remember, when we talked about ketones, we said that a ketone is produced by oxidizing a secondary alcohol, but we can't oxidize a ketone any further. So all that we need to do with a ketone is we put our ketone in the bottom of a round we put our alcohol in the bottom of a round bottom flask, our secondary alcohol, we add an oxidizing agent, and we just heat it. We don't have to worry about it further reacting to produce a carboxylic acid, because a ketone has a double bond oxygen in the middle of a chain, and it can't produce carboxylic acid. It can't oxidize any further. So I just need to react an alcohol with an oxidizing agent like permanganate or dichromate, and I will produce a ketone. However, when I do this type of reaction here, this is called a reflux reaction. I put the Liebherr condenser vertically inserted into the round bottom flask so that anything that evaporates off will be cooled down and fall back into my solution here, into the reaction chamber. So nothing gets to escape. I don't put a bung or a cork in the top. I don't need to, because nothing will escape out of here because it will cool down and fall back down beforehand. If I did put something in the top, because this reaction heated, it would just, the increase in pressure would push it out. Now, just when I set up this type of equipment, I have to be careful to put the cold water on the bottom and so it flows out through the top. If I do it the other way, if I put the cold water on the top and flows out the bottom, it doesn't fill out this whole water column around the central tube here, and it won't work at its optimum. The other thing to note is you never want to fill the bottom flask more than 2/3, because when it heats, bubbles will form up the neck of this chamber and will bubble over. So you just want to keep it at 2/3. So that's how we produce a ketone, through a process known as a reflux. So reactions of ketones and aldehydes, the last type of reaction they undergo is called a reduction reaction. We add sodium borohydride, okay, and what it does is it turns our double bond oxygen back to an OH group, or hydroxyl group. It reduces it. It reduces the amount of carbon-oxygen bonds. So this has turned an aldehyde back to a primary alcohol. If I add the same reducing agent to a ketone, it will turn a ketone back to a secondary alcohol. And those are the two types of reactions that aldehydes and ketones undergo. Wait, let me just put these answers on here. Okay, just to check our understanding of the reactions of aldehydes and ketones, what I'd like you to do is to get a piece of paper and jot down these following two reaction schemes here. So what you want to do right now is just pause the video and copy these down onto a piece of paper. Once you've done that, what I want you to do is write the answers to these three different reactions. So we've got the three different reagents, two reagents we could add to propanol, an oxidizing reagent and a reducing reagent, and the reducing agent we add to propanone. Okay, if you've started the video again, here are the answers. If we add the reducing agent, sodium borohydride, to propanol, we get the propan-1-ol. If we add the oxidizing agent, we get propanoic acid. If we add the reducing agent to propanone, we do get a secondary alcohol. However, I didn't write its name here, but its name is propan-2-ol. Okay, you get that, propan-2-ol. Oh, hopefully everything went well and you got these right and you understand a bit more about aldehydes and ketones. If you have any more organic chemistry revision you need to do, look out for the extra videos we put on here. Just click subscribe, share it, and leave a comment if you have something that you want to ask or anything you have to say. Okay, thank you.